The one I like is anionic. Also known as the Michael reaction. No relation. Right? Oh, you guys are asleep. Okay, so it requires a basic anion initiator. We'll talk about one in a second. And it also needs a carbon-carbon double bond. Right? And this is just lots of different R groups. But you can see at the end is this double bond. And what happens is that if this is electron withdrawing enough, then this initiator can add to that carbon. And we'll do some specific examples here, and you get this. And now this anion, if it's stable enough, in other words, if this is electron withdrawing enough, then this thing will then react with another monomer. And you can see what's going to happen. This is just going to keep on going. Now, this is very commonly done. The initiators are typically very strong bases, like lithium, a butyl lithium. So that's 1, 2, 3, 4 carbons bonded to lithium. When the lithium separates, it's now got a very strong base, and that's used for initiating polystyrene. Polystyrene, here's benzene ring, and bonded to two carbons that have double bonds between them. Right? That's styrene. And this is electron withdrawing enough that this thing is stable, lives long enough that it can now react with the next styrene molecule, and it keeps on going. That's polystyrene. Now, it turns out you run across this all the time. So we want to use something that's... I'll tell you about this fellow here. He just passed away. Harry Coover, chemist, material scientist from a long time ago. He just passed away. He was at Kodak Chemicals in the 50s and 60s and 70s. And he just got just a year or so ago, got the National Medal of Technology and Innovation from President Obama. He invented superglue. Superglue is made from a monomer that's called methyl cyanoacrylate. And I'll show you what it looks like. That's methyl cyanoacrylate. Here's the cyano group. Here's the acrylate group. It's an ester, right? We talked about esters last time. Methyl cyanoacrylate. And it's this thing here where all the polymerization takes place, just like we've been talking about. Except here we've got two electron withdrawing groups. And they're very good at withdrawing electrons. And so what happens is that I can use even a weak base to get this guy to go. In fact, the base superglues uses is just hydroxide ion. Anytime you have water around, you've got a small amount of hydroxide ion. And so the hydroxide ion adds to that double bond, here I can put my acrylate group up here, and then my cyano group down here. And of course, when I do that, I get the hydroxyl on the end, a new carbanion as it's called. Oops, cyano down here. It just added across this double bond. And of course, this now goes on to do the same thing with the next cyanoacrylate molecule. And I'll build up my chain that way. So when you open that container of superglue, what starts the reaction is water in the environment. They had to package it with very, very low water content because the water in the environment is the initiator, or the water on the surfaces that you're going to glue together is the initiator, like your two fingers. You've already done that. It literally rips the skin right off if you try to separate it. And water, of course, skin's got lots of water in it. It acts as an initiator. And also, why this is a glue is because this hydroxyl could have been bonded to a surface. For example, if you have silicic acid, which is the next one we'll talk about, on a surface, that's in equilibrium like that. Oh, here's a base. It can react with the cyanoacrylate, and now I have covalently bonded the growing polymer to the surface. That's why it's an adhesive.